More examples. Oh, what fun. A, B, C, D, E. Limit as x approaches 0 from the left of the absolute value bars of x. That's a good one. So let's try, I'm going to do it with the table of values. I'm going to choose all the values that are less than 0. And I've already goofed that one up today, so I'm not going to goof it up again. So I want to be on the left-hand side of 0, which they're going to be negative. So negative 0.1, negative 0.01, negative 0.001. Those are on the left-hand side of 0 and getting closer to 0. And I'm going to put them into the function, which is to take its absolute value, which means the absolute value of negative 0.1 is 0.1, 0.01, 0.001. So if this is going to continue, this is going to approach 0. And guess what? You're done. Now, how many of you remember what the absolute value function looks like? I hope you do. It looks something like this. Okay? And we're going to talk more about that. And on this side, it's y equals x, and on this side, it's y equals negative x. And so if you're going to approach 0 from the left-hand side in this one, notice that all your values are going to be bumped up to the positive value. Okay? Because that's what this says. This is y equals negative x. So if I put in negative 0.1, it's negative of negative 0.1, and it comes out as positive 0.1. And we're going to talk a lot more about that in just a little bit. But keep that in mind. Okay, F. Let's say f of x is equal to a composite function. It is going to be a function that's going to change what it does depending on what values of the domain you put into it. This is called a piecewise function. It follows a different rule for each segment of the domain I put into it. So for all values less than 2, it's going to follow a parabola. And for all values greater than or equal to 2, it's going to follow a linear function. I like to talk about these as multiple personality functions. Okay? It all depends where you get them in the domain. So just so that we're all very clear on what's happening here, at x equals 2, from x equals 2 and up, it's going to be linear. So all the way to x equals 2 and up, it's going to be linear. And all the way from 2 down, it's going to be quadratic. So in other words, it's going to follow that rule when it's on that side of 2 in the domain, and it's going to follow that rule when it's on that side of the 2. And I don't think I can explain it any better than that. Okay? It's called a piecewise function, and get used to them. Most things in life don't follow one function. Do you remember that example we did? That's a piecewise function. Many, many pieces. These were piecewise functions. Okay? Lots and lots of them. Okay, so, and what I'm going to ask you is 2 questions. I'm going to ask you, what's the limit as x approaches 2 of f of x? This is a two-handed limit, two-sided limit, left hand and right hand. Which means I have to be interested in both parts as it approaches 2. Because when it's on the right-hand side of 2, it's going to be linear. And when it's on the left-hand side of 2, it's going to be quadratic. So that makes things a little bit interesting. So we need to both sides of 2. So we're going to break this up into the limit as x approaches 2 from the left. Now as x approaches 2 from the left, f of x that I'm going to be using is x squared plus 1. And I'm going to look at the limit as x approaches 2 from the right. And when I am on the right of 2, it's going to follow x minus 1. So we can do a table of values for each. I'm going to choose values that are less than 2. So 1.9, 1.99, 1.999. And we're going to follow x squared plus 1. And over here I'll choose values that are greater than 2. So it's 2.1, 2.01, 2.001. And I'm going to follow x minus 1. And then guess what? You get out your calculator and you do plug and play. So 1.9 squared plus 1, 4.61. 1.99 squared plus 1, 4.9601. 1.999 squared plus 1, 4.996001. Now, if you want and you have nothing better to do, you can keep going. Be my guest. Feel free. However, I think we can agree that we're approaching 5. And chances are you could have figured that out after doing just 1 or 2. But be careful. Don't make a mistake. 3 is the general accepted number to put in. Over here, plug and play again. 2.1 subtract 1, 1.1. 2.1 subtract 1, 1.01. Don't use your calculator if you don't need to. Look for what's happening. And again, if you have nothing better to do, keep going. Be my guest. You and Zeno will deserve each other. You can keep going half the distance and half the distance and half the distance. But we know that this is approaching 1. So, the left-handed limit equals 5. The right-handed limit equals 1. What does that mean for the two-sided limit? There you go. They're so afraid to say that. It's so funny. I think you just don't want to be mean to the limit or something. You don't want to deny its existence. It does not exist, darn it. Okay. And how do I know it doesn't exist? If someone said to you, how do you know? You would say, well, dude, the limit as x approaches 2 of negative 1 of f of x does not equal the limit as x approaches 2 on the right side of f of x. And you'd walk away and say, whatever, talk to the hand. But that's my reasoning, right? The value that I'm coming from the left-hand side does not equal the value from the right-hand side. That's different than one of them not existing. That's a different argument. If one of them didn't exist, you'd say, hey, they don't both exist, so the two-handed limit can't exist. But this one, they're not equal to the same value. That's your argument. Now, but I do have a question for you just before we go off this question. Can you please tell me what f of 2 would equal? Which is a different question. Anybody? What's f of 2 going to equal? You don't have that nice little graph to look at. Ha ha. What's f of 2 going to equal? 0. What a great choice. Wrong. Not 0. It doesn't. Is it undefined? My goodness, you guys don't read. Huh? 5 and 1. You want it to be 2 things. It wouldn't be a function then. Can't be 5 and 1. No. F of 2 equals. Oh, it can't be undefined. Whoever said undefined, I really want to throw hard things at you. It is definitely defined. When x equals 2, we follow that. So if you put in 2 for x minus 1, you're going to get 2 minus 1, and the answer is 1. But notice I don't put the equal sign in here. Don't you dare. I will notice that, and I will take marks off. And you'll say, but sir, and I will not care. This is a limit chart. It does not equal 2 in a limit chart. Okay? This is greater than 2. Just when you thought you were done, you're not. Let's do one more example. Limit as x approaches -1 of f of x given. F of x is going to be a multiple personality function. It's going to be x squared plus 2 if x is less than -1. And it's going to be -2x plus 1 if x is greater than -1. Can you read that at home? I don't think that you can. Now you can read it. So this is the question. It's a two-sided limit. I want to know the limit as x approaches -1 of f of x. And I'm going to tell you that f of x is a multi-personality function. It's going to be quadratic on the left-hand side of -1, and it's going to be linear on the right-hand side of -1. And notice there's something missing there. It should bother you. It should bother you greatly. Yeah. Equal. There's no equal to. Guess what? This is not defined at -1. Okay, so this one's not defined. It's not equal to. So when I go to do this on a graph, and when I'm at -1, I better not have a range value there because it's not defined. On the left-hand side, it's going to be quadratic. That's fine. On the left-hand side, it's going to be linear. That's fine. But notice there's no equal to. It is undefined. F of -1 is undefined. That's okay in terms of limits. We don't give a darn. So we're going to have to look at both sides of this of -1. And notice that's where the change is. So we have to look at both of them. So we're going to look at the left-hand side, the limit as x approaches -1 from the left. If I am on the left, I'm following the quadratic. And you're going to have to look at the limit as x approaches -1 from the right. And if I am on the right, I'm following the linear. So then I would set up my table of values. I would choose some values that are less than -1 to the left of -1. So -0.9, 0.99, 0.999, and then we plug and play. So 0.9 squared plus 2, 2.81. 0.99 negative squared plus 2, 2.9801. I think I know where this is going. I think it's going to 3, and I actually could stop, but maybe I'll keep going just for fun. And so it's 2.98, well, no, sorry, 0.999 squared plus 2. Olivia, I think your friends were looking for you. I'm sorry. You're going to be a little bit late coming out. But that's going to go up to, if I was to keep going, I think we can all agree that that's going to approach 3. And the other side, for x greater than -1, so -1.1, -1.01, -1.001, and it's -2x plus 1. So plug and play. So 2 times 1.1 equals, so this is 3.2. 1.01 times 2, so that's 3.02, and this will be 3.002. And if you have nothing better to do with your life, you can keep going. But we'll pretend that I have something better to do, and we'll put a 3 there, so that's approaching 3. So guess what? The left-hand side equals 3? Well, first of all, the left-hand side exists. Yay! The right-hand side exists. Yay! And they both equal each other. So since, if you really want to sound smart, you can say since the left-hand side of f of x equals 3, and that equals the right-hand side, I would be so happy if you did this on a test. I would be like, oh my gosh, I taught them something. So since the left-hand side equals 3 and the right-hand side equals 3, you could then say the concluding statement that the two-sided limit as I approach -1 of f of x not only exists, but it darn well equals 3. And I would be so happy. I would think that I did something good in the world. It would be lovely. Okay, I'm going to pause the video there, and we will be back in a few moments.